Are you early into your journey of trying to learn and discover what ham radio is, and have come to the understanding that perhaps it seems to be more difficult than it should be? Are you looking for someone to break it down into a more simple, visual way to understand and learn ham radio? Then you've come to the right place. I've done a four-part series on the basic introduction to ham radio. Today is part three, and I'll be covering the HF bands. So if this sounds like something you'd be interested in, let's get started. Hey, this is MJ, call sign KO4TWA, and welcome to another episode of Ham Radio Made Simple. This is part three in the introductions to the basics of ham radio, and I'll be covering the HF or your high frequency bands. Now, I broke this into a four-part series. Parts one and two were directed to those who have their technician's license and have access to the UHF, VHF bands. Parts three and four, which we're getting into now, are going to be directed to those getting their general license with a focus on the HF or your high frequency bands. Now, this is part three. Let's get going. Topics to be covered: ham radio HF bands, what are they? High frequency principles, propagation, and why does it matter? What equipment do you need to get going, and what is the cost? HF equipment by manufacturer, and where do you go to buy this equipment? Now, just a quick refresher, when we talk about license access on the HF bands, as a technician, you had some access, but it was very, very limited. You had the 6 meter and the 10 meter single sideband portion, which really wasn't much. It's when you get your general license that you have access to the HF bands, which account for about 80% of all licensed HF bands. And a quick refresher, what are those bands? Now, 6 meters to 160 meters is typical what you're going to find on the equipment, like this base station, for example, to operate in the HF world. So if you remember this wonderful ARRL amateur radio bands, it was really confusing, but hopefully by now it's starting to look more familiar. So now if you get or have your general license, anywhere you see a G, you have access. So if you look, for example, at the 160 meters, you have full access equal to what an extra license classification would get. Remember that the green is the voice, the red is the data, and you need to pay particular attention to the frequency ranges. So if I'm looking at 10 meters, for example, it starts at 29.700, goes to 28.300. That's the access you'll have. And you have to look at that at each line. So here, a general at the 40 meter is going to go from 7.300 to 7.175. So pay attention to the frequency limits, the megahertz you're going to see here, as well as your classification. So when we talk about a general license HF access, to take that chart, you can break it down and do something like I did. I basically wrote it down in a Word document, and I put the limitations that you see right in here, applicable to, I think this is a general one. I have my extra license and I had to update it to the extra band coverage I get. But for the general classification, you're going to want to do something like this, instead of trying to pull out that band chart and looking at it. Now, I excluded the 30 meters because it's data only, and the 60 meters is kind of a one-off in the sense that it's a secondary basis only, which means others outside of the ham radio community have primary access first. Ham radio operators have second access rights to this. So if someone from outside the ham radio community who has legal permission to use these 60 meter channels, you have to back off and let them have it, essentially what that is. So for the most part, I don't know of too much activity that takes really place on a 60 meter channel. So if you want, just kind of leave that off, or if you want to include it, go ahead. But what I basically did is you can see where I operate my ham radio, my equipment right here. My transceiver for my HF is down here. I put something like this, and so when I'm operating at a frequency, if I don't have the band limits already programmed into the radio, I can quickly look over for 2 meters. I know I can go from 144.100 to 148 megahertz. So it's a great way to take that band chart and make it simple. And that's the goal of this whole video presentation, is how can we make ham radio more simple? So essentially, what is high frequency? Well, by classification, we know it's the 3 to 30 megahertz or your 10 to 80 meter bands. But again, as I mentioned earlier, by equipment standards, it's really going to be your 6 meters to 160 meters. Now, the HF signals are different from your UHF, VHF signals in the fact that they will go higher up into the atmosphere and they will bounce around off the different layers, especially the F layer, when we show you here in just a second. But they're going to bounce up off the F layer, come back down, go back up, and go back down. I'll show you a picture. It'll make more sense. When this is happening, it's called propagation. And it's essentially, this is the way the radio waves, your electromagnetic waves, travel in through the atmosphere depending on what type of atmospheric conditions are going on. So for example, if you're having a lot of solar activity, a CME, a coronal mass ejection, happens on the sun, in the HF world, it's a blessing because the ionosphere gets charged and now your electromagnetic wave will now travel further because of what's happening in the atmosphere. But likewise, you can say the same thing on the opposite end. When you get severe thunderstorm fronts that are happening, it will impede how that electromagnetic wave travels through the atmosphere. So typically, you're going to look around the equator area and you'll find a lot of thunderstorm activity. And sometimes it's hard to reach past the equator, not because of radio propagation being able to bounce off of the ionosphere, but it's running into the thunderstorm activity just right. It may block your signal from traveling and definitely going to cause distortion. So when we look at propagation by bands, let's look here. Now, when we look at the UHF, VHF, it's known as the troposphere, and it's called ducting. Now, this is the lower level of the Earth's atmosphere. And when temperature inversions happen, that's essentially when a high-pressure front begins to drop. Typically, this happens when a cold front approaches. It can take a UHF, VHF signal, which normally may travel, let's say, 30 miles to 60 miles, best case condition. And again, simplex call without a repeater, and may end up going 300 miles or more. So again, propagation effects even impact the UHF, VHF bands. Now, when we start talking about the HF, it goes higher. It goes up into the ionosphere. And this is where certain parts of the Earth's atmosphere is impacted by events that are going on, especially from the sun. Now, night or twilight is the best time to use the HF bands. There are ones that you can use in the daytime, but to really get the distance, it's going to require most of the time nighttime, unless sporadic E or some of these other effects that are taking place can take that signal further. Now, the F layer is what you want to reach, and that's usually at night, and I'll explain why. So if we look at normal daytime propagation, you have different layers. You have your D region right here, you have your E region, you have your F region. So the troposphere is what we talk about that's in between all of this. Now, if Colin was trying to call Katie over in London, for example, and Colin's calling from North Carolina, where I live, and his radio signal during the daytime is going to get absorbed in the D region. Okay, the D region now takes that signal and just absorbs it. So when we do nighttime, things change. And let's talk about this. What happens in the nighttime is the D layer collapses. It just goes away. The E region, a few hours later, same thing will happen. And when you're left with is the F region. And sometimes the F will split into an F1 to an F2. Now, at nighttime, assuming that the E and D regions are no longer there, that's why at night they go away. If Colin was now making that same call at nighttime, what's going to happen is it's going to hit up at the F region and it's going to bounce down, skip, bounce all the way over. Now, one of the things to be aware of when this is happening, and this was kind of frustrating for me, is to understand what happens in a skip zone. Now, a skip zone essentially is where that signal is not hitting. It's a dead space in between. So if you can picture coming up over here, this whole area right in here, people would be receiving the signal clearly. Over here, clearly. Back here, clearly. But in here, nope, not so much, not so much. If you got onto an HF or high frequency net that meets at night, You might hear the net operator clear as a bell in Naples, Florida, for example. But anywhere in between where you are, for me, North Carolina, there's people in South Carolina, for example, that are in that skip zone, and they are hard to hear, if maybe I can't even hear them at all, because the signal's traveling over them and dropping down into the location that I can hear the person from. So if you're on these nets, you may only hear half the conversation. The net operator, and a lot of times you can't hear who he's talking to because they're in the skip zone. But if they're not in the skip zone, then you can hear them. Now, when you hear the term open bands, the bands are open, means the atmospheric conditions are ripe, they're perfect, they're ideal to allow long distance propagation of your electromagnetic wave. So when is the best times to use your HF? It depends. Now, again, I'm keeping it simple, general terms, always exceptions to the rule, but let's keep it simple. Daytime, your 6 meter, your 10 meter, 17 meter, 20 meter. Twilight, your 20 meter and your 40 meter. And nighttime, your 40 meter, 80 meter, and 160 meters. Now, it doesn't mean that the 40 meters doesn't work in the daytime. It just means it's not optimal in the daytime. It doesn't mean, for example, that the 80 meters, you may not hear it more in the twilight time. It just means it's optimal in the nighttime. And the 160 meter, I'll tell you right now, is basically pretty much a late nighttime type of event. Be aware that during the summer is the best time for when the propagation conditions are right to get these electromagnetic waves to travel the furthest. So you're going to hear the term single sideband, as I mentioned in an earlier video. Why should you care about this band? Well, it is basically the majority of ham radio traffic is on this mode. You have AM, FM, single sideband. So just like you have radio, you have an AM and FM. Well, think of it as a third one now, single sideband, just like AM, FM. And this is where the majority of ham radio is going to happen because let me explain why. There is a modulation technique that was someone developed that actually suppresses one sideband and then the carrier can transmit on the remaining sideband. So what's the result of this? And I'll show you a picture of it. It's a lower bandwidth transmitting. Bottom line means it's more efficient. Bottom line means it allows more talk power. Bottom line means it propagates at a greater distance. So single sideband, because of this, is more efficient, allows more talk power, and propagates at a greater distance, is the ideal band to use. Now, it doesn't mean you don't use FM bands if you want to, but if you're looking to find somebody out there, the majority, by far, are going to be on the single sideband modes. Now, there is an upper sideband and a lower sideband. Let's keep this simple. Lower sideband means below selected frequency. Upper sideband means above selected frequency. So if we would look at our carrier frequency here, which is an AM signal, is what single sideband does, it's taken half of the signal, not all of it. This portion over here is below is the lower, above is the upper frequency. So don't get caught up into this. Just understand that when you're talking about single sidebands, it's going to be either on the carrier frequency below it or above it. And if you had an image of the signal being transmitted, you would actually see the carrier frequency, but the signal, if it was lower sideband, would be over on this side, showing up on a scope. And it would be on this side, if it was on an upper sideband, it would be above the carrier frequency, not in the center when you're using AM, FM. So right in the center is where the carrier frequency would operate. This operates just on the below side of it or the above side of it. Hopefully that makes sense now. Now, what bands use single sideband? General rule of thumb, 14 megahertz or higher is upper sideband. So that leaves your lower sideband, your 40 meters, your 80 meters, and 160 meters. And if you're looking at some of the more modern transceivers that are out there today, and the more, I call mid-tier price ones, it's already programmed in there. So if you go to 40 meters, it knows whether to go to the lower sideband or the upper sideband. But if not, you can select the mode based on this. So what do you need to get set up, and what do you think the cost might be? Let's go over that. You're going to need a transceiver, HF transceiver, and you can expect to pay anywhere from $500 to $12,000. Do you want a fixed station? Do you want a mobile station that duals both in your shack as well as out in the field? We'll go over some of that later. You're going to need your power supply, which is converting the AC to DC, $115 to $450. You're going to need a tuner, perhaps. Look to see when you're buying a transceiver, does it include an internal tuner? If it does, then you most likely won't need this. There are exceptions. For example, if you use a random wire antenna, those internal tuners most likely don't work for it. But look at $150 to $600. You're going to need some kind of outside antenna. Expect to pay $60 for a simple random wire antenna, $5,000 on up for those who are really serious trying to put up those towers. Inside, internal grounding is very, very important. Best practice states that you want to take all your equipment to a single point of contact onto copper. So it could be a copper pipe, a copper plate, and here's one that I bought off of Amazon. They have bolts that I actually can connect these type of copper braided bands from my equipment right onto here. So just picture a nut and bolt basically holding that down. One of these is dedicated only for the 6-gauge wire that's going to go out to my external ground. So all the grounding happens at one point and it all goes outside. Power connector box, maybe. I use it because I have multiple pieces of equipment and I also want the extra protection of fuses right in here. So my power supply would come into here. This is the in, power in, special fuses. And then each of these go out to different pieces of equipment. And I use these quick disconnect system here from Anderson. It's really, really nice to push them in and push them out. It does require some extra learning curve on how to put these on. But once they're in, if you're in a, I call it a dual purpose role, you have a base station as well as a mobile environment shared with your equipment, then this is an absolute must to have. But if you're connected to this type of rig runner, you're going to be required to add these to your wires that come off your equipment. Base station antennas are critical. Outside antennas, when you're looking at it, can run anywhere from like dipole antennas that you have here. And again, don't worry about trying to learn all of this. I have more slides talking specifically about antennas, but you have many, many options, whether it's a wire antenna, whether it is a vertical multi-band antenna, whether it is a Yagi, a directional beam, hex beam. There's all different types of antennas. But you need to really look at this and consider this is equally as important as your transceiver when you buy it, because if you don't have a good antenna, you don't pick up a good signal, your transceiver is worthless. So we look at the outside part of your shack, down that everything was connecting outside, your 8-foot buried down deep ground rod, solid copper. It's either copper or brass connector right here. Your wire would fit right here. Your 6-gauge wire runs inside. These are called lightning arresters. Consider them like fuses in a fuse box. Now, coax cable will be the next couple slides coming up, but just wanted you to be aware that that's something you're going to have to buy and invest in. Typically, you're going to see in the United States, you're going to look at, see, PL259. That's the connector right here off the end of the cable. So what you've got to make sure is your transceiver and your other equipment, what is the connectors that fit on the back of your transceiver? Is it a PL259? Is it an N connector? I would assume most of them are PL259, but again, don't assume. So make sure you're aware of what is the output connector coming off the back of your transceiver and what cable that you're buying so that it matches. The female side is the SO239. This is similar to my utility box. What you're looking at is your cable going up to your antenna, going up here. Mine could be the UHF. VHF is one antenna, and the other antenna is my HF. This is your lightning arresters. They're your fuses. If there's a large discharge of static near your antenna or a lot of wind going over your antenna, it could actually cause a charge to come down your cable lines from the antenna and go right up into your shack, into your equipment. That's what these fuses protect. Are all 50 ohm ham radio coax cables the same? No. So don't cheap out when it comes to selecting your coax. They're not the same. Do your research. Understand how you need to use that cable. What is the length of your cable? Mine's 150 feet. That's a long way. Can you bury the cable? I had to. Is it UV resistant? They're not all UV resistant. What is the attenuation, which is the lowest signal loss in DBS? Basically, am I going to lose any of my signal strength due to my fact that I have bad cable, coax cable? So you want to look at these things, like the power ratings, the efficiencies, all of these come into play when you're selecting the right coax cable. One of the things you want to look at, we want to prevent signal loss. The other thing is to reduce failure points. And finally, we want to reduce interference and noise. And that's based on the shielding and the quality of the cable that's in there. So choosing the right cable is critical. So let's talk a little bit more about that. So when we go by sizes, there's a lot of them. These are all 50 ohms. You've got your RG213, your RG58, your RG8X, RG8U. Well, which one should I use? And again, what are you trying to use it for? I use the RG213 because it has a very, very low loss, has all the protection that I need as far as being able to go outside, buried in the ground, etc. This happens to be military spec, which you know then is basically high standards that are required in order to produce the RG213. But if you're just doing a mobile installation, you don't need the RG213. If you're doing shorter cable runs, you probably don't need the RG213. So, and there's another option for the from the RG213, you can consider the RG8U. Now, this happens to be from DX Engineering's paper catalog. And I just wanted to show you the choices that you have out there, because you're going to want to look for the quality, and you're going to also want to look, for example, the performance. So again, if you want to hit the pause, look at this. This is what I use for my UHF, VHF, because it actually can handle the higher megahertz. Now, remember, when we're talking about the 70 centimeter, that is 420 to 450 megahertz. And so this cable handles that very, very well. So this is what I use, for example, for a long run, able to bury and use it for my UHF, VHF, where I use the RG213 for something else. But if you go across, this one doesn't show you that you can do a direct bury. It doesn't show you it's UV resistant. So each of them have their pros and their cons. This is why you have to do your research, look at it, and then you can look at the pricing down here and see what you can expect to pay. Connectors, as I mentioned earlier, there's a lot of different choices. Typically in the United States, again, get familiar, PL259 male, SO239. Most commonly used in ham radio. And again, that's what it looks like. Now, you're going to see N-type connectors used in Europe and Asia. I think it's a better cable connector. It's much smaller in size. It's watertight. There are some manufacturers and some pieces of equipment that are using the N-type of connector. You'd have to use some kind of connector in between the two different forms here in order for them to connect. So one of the things I've learned reading on one of my antennas, they had a connector that used an N connector. And they basically said warranty is voided if you tried to use a PL259 and stick it into an N-type connector. You'll damage it. It really doesn't fit. And at that point, you're hosed. So pay attention to the connector types off your equipment, on your cable, off your antennas. Very important. Now, you're also going to hear BNC, which is a quick disconnect connector. You'll see this on some of the handheld devices off of your antennas there, where it's a really cool way of doing it. This happens to be an elbow. It doesn't have to be an elbow, like a 90 degree. Some of them are just straight up. And this allows you to do a quick disconnect off of your handheld antenna and being able to take it off quickly, stick it in a bag without trying to unscrew it all the time. Because over time, if you screw it and unscrew it, the threads will wear out. And what you'll hear is the SMA, which is the type of connection used on the antennas on your handheld devices. Now, real quickly, what is the order typically of setting up my equipment? Well, you're going to start with your antenna. It's going to go through your cables to your utility box, through your lightning arrestor, tuner if you have it, and then it's going to go into your receiver, to your power supply, and make sure that you have a ground fault protection. Again, don't buy the cheap little white strips with the little red button on the side of it. Make sure that you have something of quality that's going to protect your equipment from any kind of power surges that happen. Now, whether it be my tuner or my transceiver, I'm going to go to my grounding station. Remember we talked about this? And the grounding station internally is going to go to my exterior 8-foot ground rod. Next is going to be my power supply. My tuner could go to the power supply, but the most thing is my power supply goes in, these go out. So outside of this is going to go from here to my transceivers, to a tuner, or whatever else I need. Now, you're going to find that you're going to end up hooking up, whether it be a laptop or a PC, to your monitor. There's a whole process in this, and they require special cables. And make sure that they are good quality cables, or you're going to have to put some ferrite cores over those to protect them from causing noise, RF noise within your radio. This is where RF noise, a lot of times people don't become aware of it until it's kind of late, is when you're trying to connect it through your computer. So FYI, again, another video when we're talking about noise, specifically talking to your computer. So let's talk about options that you have out there. You can look at Icom. You can get a dual-purpose mobile home-based system for $850 multi-band. You can get the Icom 7300, which I have, HF only, internal tuner included. It's about $1,100, most popular radio out there, and it has the best videos as far as showing you how to use the equipment, which helped me shorten my learning curve really, really significantly. They came out recently with the Icom 705, and this is truly, like I call it, a backpack type of HF device. It has the battery actually built into the unit, and so you don't need a charging station. You don't need to have a battery to haul around. This all needs a car battery or into your power supply system. This is built into it. $1,300, thus the price. It's only 10 watts, but again, multi-band. This is a backpack type of option that you can look at. Yaesu makes outstanding equipment. They have called multi-band, does all the bands, 100 watts, internal tuner. The FT991A, a great choice, $1,240. And again, remember, this is multi-band. You don't have to have two devices to operate in the UHF, VHF world, and the HF. They have a great mobile unit for $700. It has 100 watts, outstanding. So great choice here. They do have a multi-band, but it's only 6 watts. I'm not even sure I see it much in a lot of the catalogs that much anymore. Now, Kenwood pretty much is not in the lower end of the market. This is basically going to find in the used. Where you see Kenwood today is starting at $1,430, HF, 100 watts, and it goes up from there. Again, high-end, high quality. This happens to not have the GUI interface, touchscreen, waterfall. It's all knobs and buttons. It doesn't make it less of a radio. It just makes it a different interface type of radio. You get into their more higher end radios and they'll have the waterfall and the touchscreen capabilities. This is all basically buttons and knobs. When you look at BridgeCom, for $450, you can get a UHF, VHF, HF, 20 watt mobile, or you can put it as a fixed base station antenna. Great option to get started. It includes an internal tuner. Now, it doesn't have the whistles and bells. It doesn't have the touchscreen capabilities, the high-end filters, etc. This is where you're going to get down in your prices, is really your filtering capability. But man, just to get started, great choice. This can always be your mobile device later on if you choose down the road to buy a more higher-end transceiver. Alinco has an option out there, but at 10 watts for $600, go with the BridgeCom. So where do you buy this type of equipment? Not at Costco, not at Sam's Club, and believe it or not at Walmart. There are specialty distributors of manufacturers' products, and there's like 4 or 5 that I just really want to go over. The first one is DX Engineering. I bought a lot from them, great customer support. You actually can talk to real ham radio operators who know what they're talking about and will help you understand your choices and direct you to the right products. Ham radio outlet. Nice thing about them is they have multiple stores throughout the United States. So if someone is out of stock with something, check them out, because one of their stores most likely is going to have it, and they ship from any of their stores to anywhere in the country really quickly. I've used them quite a bit. Gigaparts is unique in the sense that they have special vendor relationships, exclusives with certain manufacturers. So there'll be things on Gigaparts you may not find on the other distributors that are out there. R&L Electronics have been around for a long time. Again, another place to check for equipment, pricing, and availability. eBay, Amazon, it's up to you to do that. I'm kind of reluctant, especially when it comes to high-end equipment. Is it a knockoff? Is it one of those Chinese knockoffs that you don't know? So be careful. But if you feel and you're sure that you're going to get what you think you're getting, go for it. Other option is manufacturer direct. There are manufacturers out there like MFJ. Now, a lot of their products are on those distributors' websites as far as purchasing it, but there are some of it that is not. So you may want to go direct, which I did in one particular case. So they have other companies outside of MFJ. You're going to hear High Gain, Cushcraft, Mirage, all part of their umbrellas. West Mountain Radio. Now they specialize in distribution and controls. That's where I got my Rig Runner power box that you saw earlier. Chameleon Antennas. Now they'll be listed on some of these distributors, but they're always coming out with new products. So you may want to check their website directly. SDR Play, based over in the UK, they get into what is known as software-defined radio. It's basically merging software and ham radio together. So you could have a ham radio that has software in it. It's embedded into it. Or you can have like a little box that I had shown from a previous video that turns your PC through software and that device into a ham radio. Now quickly, remember single sideband is a mode just as AM, FM is. There's an upper and a lower sideband. This is where you're going to find the majority of your activity on ham radios taking place on the HF bands, single sideband. We went over the equipment, the investment. There's a lot of moving parts. Hopefully what I've shown you will help you. Directed you to the different vendors that are out there, and I'll put links to their websites in the description below. We talked about propagation, which is really critical. So if you see CME activity, coronal mass ejection taking place on the sun, is when you really want to jump on ham radio at night, because you're going to go a lot farther than you ever thought you could with your signal. And again, make sure you find a seasoned ham radio operator who can help you get set up and moving forward. Upcoming videos, part 2 will take place here shortly. I'll get into licensing and deeper dives, not necessarily in this order, but most likely. So if there's anything that you want me to cover, just put it in the comments below and I'll include that later on. Remember, if you liked what you see, please hit the subscribe button and the like button. I would greatly appreciate it. This is MJ, call sign KO4 TWA with Ham Radio Made Simple, out.